You. This is Professor Kharagpur. I give lecture in today's on design of rainforest, particularly on multi-storied frame. Before we start with the multi-story, please allow me brief concrete and understanding so that it will understand solving problem structures and concrete, that is the which is associated with civil engineering having this particular material backbone of civil engineering. Wondering me that no or the mint that is most congealed. Why second? Drinking water. The important material which is made by mixing segregates, coarse segregate and water. Why have? Because it creates problem. Water more them, and if you add, then also you are having problems to achieve. If you then water will drain out that casting, then you will find out there are, and we call it honeycomb. If the water is happen that all the metal be wet and you will not get the required. Just to give you demonstration this that we are having coarse aggregates, cement I have told already, and that water proportion to water to cement. That's why I have cylinder near cement ratio. We call it reinforced concrete because as you all know that is very very, so that's why, because the thing is that world you will get only compression also, so that you will have happiness as well as, so that tension who will enforce, one will look after, and we have to deal in a proper position so that act as a brittle, it will work. This is your another kind of material that actually beams where we have to provide this reinforcement. Just this is the one reinforcement that is near support that we shall find out later on also. We are having stirrups. So one is mainly we design and for shear, and whenever we are having this in addition we shall have, this is the one we have told you. So our objective, diameter of this bar, diameter of the bar, diameter of bar, bars, how can we provide between these two things we have to provide in. Whether it will too far away, so those, this is your, now what is this one? The reinforcement, but certain ducts used for say wire, maybe different, I can use it here, that using that is that where shall we provide the duct or shall we provide the duct. So that is your another issue near the bottom face, because told concrete is weak, not consider tension. So that means particular beam, there we don't want to descend, we can use the then provide the duct. This is called actually spiral to make it. So that is another two idea. Now one more one actually your form, because the thing is that time the concrete is butter only. So of the proper support only it will work. Otherwise what will happen, because we get the strain information as you already achieved that one, we require 28 days, which is called actually correct. Another important part, this support is very because this should give proper care that one of them, because of there will be leakage during construction, during casting of concrete, then if it becomes loophole, and if one of them actually, then obviously it will be like a will fall and the whole of construction. That's the care for the support system. This is the why I have chosen these certain granny bags here. Actually curing, we have to cut concrete, we have to cast, we have to put water, and that is structure. It depends the cheap, that depends on the curing. From another one from the, now how do you, for example, here you can be happy and that for all other engine, that means for steel manufacturing or any computer, all those things you, but in civil engine the vacant land, that cement, the stone chips, and then getting the, so it is, you can do it very easily. At quality control we have to ask. What we do, we generate millimeter cube minimum for a particular cubic meter of concrete, that we test it to the strength. So one important concrete, and then one of the one testing machine civil engineering department structuring at IIT Kharagpur. This is a very milestone, it is still working, and put that cube here, put the load compression, it fails the strength of the concrete on the 28th day required. But just to give you idea, now let me give you these things we are doing, kind of standardization from the Himalayas area, the other sides, or northeast to southwest. So everywhere, so we should have certain, every country having their own. So this is the basic 56-2000 codes having certain numbers. So that way, that means it has started with like that IS code, that one for that how the national flag how to make. So that is a case one. Just this is for in. So this is the plain and reinforced concrete course 2008. First time the 19th method was introduced, and then gradually, and there is another method that we shall cover also. Now part that how to design side also there, that code of practice in earthquake, because earthquake is considering and structures. Number one, because how much load you will prevent. So we are having the 5 which standardized load. The imposed load or we could. Next one we are fourth part snow loads areas you can consider. Then we are having pressure loads, very important here combination. So that means you are having superimposed load, that one as a gravity load. Lateral load will come from for earthquake, and we shall consider. Shall we consider together, or similarly we consider that one wind load? When we shall consider wind load, that load, and when we consider earthquake load. So these are many more things are there on list. Now this is your IS event 2. There are the part 1, the extent design of structures, buildings. We shall. Now I have told you the thing is that I should tell something. The thing is that please allow me not biased. Only thing is books. So that introduce that. There are many more known to me, but those books which I am going to introduce conversant with those books. One obviously this is not, but this book you can level of concrete written by AM. This is the one whenever we have any try to find out that neither it is available in cook, we always find out that said, and from yes whatever it is stored. So this is you can consider this in concrete. This book SK Mollik and AP Gupta, actually professor of civil engineering. This is one part. But I first undergraduate and this limit first book that one we have found explained. I follow this book because that only one book possibly that is this book. So this particular book I consider me till today. This book is very design of reinforced concrete sort of IIT Madras. Very good book, and when I was teaching this subject, basically I have followed this. But another book, Professor Dwaratno at Kanpur, this is also another book that also limited design, very good book that was. Kind of concrete structures. This is of the other books. This is very recent, but this is also written by Professor of Civil Engineering. To give you certain idea regarding design of reinforced concrete. One we have started immediately for each and every discipline. So different stress method, length and serviceability method. This is the thing I can say, call it limit state method. Also you can say form of limit state method. Only load factor method that way you design. Strength of all of them limit state method, and limits of different thing. Whatever you give limits to not only as your deflection you can give, and that's how you call it. There I prefer to use that because there are so many limit states. Reasons towards ultimate concrete sections behaves ultimate more rational selection of the stress strain curve for concrete time dependent. It is not linear. It is time dependent because it varies with respect to time. So obviously one is visibility. If stress requirements alone, the service loads may be excessive. It is necessary to keep flexion within desirable. I can say this. Let us consider your one slab which is that made of glass from the top. Now the issue obviously you will not feel all that since it is made of glass, it may break. Discomfort it will come, scared, and here also let us say that if you go that one I can say no, but even if you have excessive or if you are having that cracks, wide gap of crack comfort, to avoid square that serviceability level also even it does not, so you have to consider that users should not be set method a limit state states in which the structure. So as I have told you that way excessive vibration can also be operational, but so that's why we shall restrict things that we restrict and different limit states. That's why this may be classified broad. One is serviceable in respect of backing. Mainly we consider that means what will be, let us consider a beam flexion at the midpoint. Similarly, the cracks if load in a simply supported given vertically. So you this particular problem limit state of failure in resistor, flexor, torsion or combined effect. So failure not only it can be due to mainly flexor. Okay. Just to come back to, let us consider this is a beam and deflection in the deflection here. Now if this is L, L means span. Then what will be the much shall we allow so that feel discomfort on this end to this end, you will not full discomfort lower, then you will feel it is called actually serviceable limit. Similarly, that loading say applied in the head, then objects may develop these cracks. What will be the crack? That also we have to give restriction. One we can consider it is a part of. Coming to again the PowerPoint serviceability limit state of effect of deflection and crack, respect of shear, torsion, bone, axial also one. So that way we can have. Now one important characteristic strength that one can see materials are strengths. So we are having one shall have one characteristic strength which can safely assume particularly for steel also. Now let us see what it says strength. Value of the strength of below which percent of the test results are. So if percent safe will it is not possible. Statistical manner if you say that characteristic strength of the material below percent of the test results are, so that means 95%, then also we are happy. What means that the structure has and for which is called the. So we are having shall consider that one at 75 that is follow that. So let us again 6 because IS 45 follow when we are going to reinforce concrete structures. Load means that is 95% exceeded the structure. Probability of not being exceeded. We are having a life years and on the will decide that 95 not exceed, that we can say. Refer that one that 5%. So 5 are expected to fall. We are telling 95%. As I have told you earlier, this is obviously dead load or self. Whenever you are talking the self, there are different are available. Consider say one column having beam. So if a floor, that means let us a beam. This is column. Similarly, this column say. So if you a thing like this, on the bottom, if there you do is not covered with the fall, you will find out this. You will find out the rib of the beam, and then we are having one slab. Now, there in the bottom, actually there is a thing that plastering at the bottom. Then you portion, we call it floor finish. So if dead load which is weight, the then we are having tiles nowadays used as full frame. And number 4 rib, the part of your calculate that the here whenever you, I can give you one egg, whether the chicken or the egg first. When you are going to structure the same, because you what is the thick, you do not know the depth of the rib, but you have to. That's why the issue comes. Do not know then how shall you start certain thing, and if then you have to think all right or not. Dead load. Now the thing that one that is our to find that one in a particular load will come. That means sitting now you are having frames, others, so many tables, other things are there. That what is the weight of that part? That what is the weight of that? We call it actually super or we call it live load. This information is in IS. Then we are and earthquake loads, that on wind load obviously say dead load and live load, that one it will act vertically. Wind load it will say cyclone, other things if on the side. Earthquake load it, and because of that so will be in the lateral direction. Different structural elements, that one thing we are having different structure. So if we consider this one below, then though we do not construct, just to give you idea why this one's like this, that finally it should be transferred to the earth. What is the, how, if you can imagine that one, that for example immediately after rain, then you will find one whenever you are standing print very distinct manner, but find out that. So bearing capacity can take. Now of the soil is less compact, so what we do, we make it so that one will be less. One first we found it. Over the schematic one and columns, we provide tie bar also, though we at this level we make it. Construct this beam and your idea that so thing is separate, but actually you construct then your slab. And this is the how it moves. So that means have the columns which will bend one after another, it will. So these are the different. So what are, if you really consider, that means, and then obviously, so beam and slab, and then we are having, say we call it tie beam, and then column, and then you have to design this. If you come back here and this column, what this column axial load more really govern means and means axial also may come, the two things that it, this is the basic difference, but whereas you will find bending. So do for the design for bending first, and then if it is not, then whenever you are going for column, then and then you are having bending. Bending because seen that others are not bend. If you really see 4 of flexure, shear and torsion. So it can be, when I am talking beam and shear, whenever you are talking bending, whenever you are considering, does not mean that shear is very less. For that, with the minimum provided for a slab, that your shear or axial automatically it is checked perfectly all right. Design for bending, the rest will be taken. But the thing is that whenever you are consider this one as a thin or thin, you can consider one cloth which is mainly governed by, but whereness actually more that slab, the shear, and if it is more. So on what about shear? Is it need? I have told this one governing one. Whenever you are talking column, governing one, check axial in earthquake and others, that it happens that one, that means here that how much is the shear. Example that with the multi having that column, objective is that force is coming or not. Our objective here shear, that we are considering this one M over Z. If we consider shear or let's say in another direction, makes MOI like that. So this is axial, and then we are having one and one normal, that is Z. Think that Fy, which is now issues here, we can find out that is more, check it. Other then we didn't know. Another question, doubt about shear in case because of the lateral, in that case that picture, and we have to check it. We shall show that one at the end of this lecture to that level today. Explain that one, that whether we do. So another code that check it. Which let us come back to limit state. This particular one you have analyzed the recall that this is whatever you have done in a problem. Simply supported beam, its same is solved like this, and this one say 10 kilonewton, and most of the cases that either or EI give and thus length. In design you have to provide that edges, or I can say further is it like this, light, other things there. So what type of section, and as I have told you, this but weak in tension load, it will be from portion. So since you have tension reinforcement, the issue this type of thing or always relevant. So that is the one. Quickly go through the limit state. One is that on shear, axial and torsion also. So it may be that flexure, any particular you can have only flexure, you can have flexure and axial, so like that. Any more combinations you can have. Here plane section remain plane after being, this is the one. You can assume that your pages in a book you tilt remain plane. So that is the not work. But if you consider that book which has become the water other thing, then we will find. So just to give you that what do we mean by plane, book where even if all pages will, is the idea of that remain plane. The maximum strain in concretion fiber is taken as, please note this one, this vital number here. So we are talking this one 5, that means that is the strain that it will 0.0035. I told you in the very beginning, concrete is ignored, strength will come, we do not comment. The stress block to be rectangle or any other say prediction of strength, agreement with the results of whatever you have done, nothing else, but rectangle also, trapezoid also, and only provided these results in pedicel agreement with the results of test. The stresses in the representative stress used, so which type of that? For design part of gamma m equal to 1.15, still we use 1.1. In the tension, please note it, we have irrespective. How do it is decided? Proportion of cement, core segregate, water cement ratio. We can find out, but cement, sand and core segregate ratio, what will be the corresponding? True for all grades, it will be 0.0035. Steel, there's different grade of steel. We found out by Fy by plus point. This is the one that card, the first one that characteristic strength means if you say M20 grade, FCK is equal to 20. M25 grade of Newton per square millimeter, 8 days after completion of the strength. 0.67 FCK. Again, why there are two levels that you are giving designers, 2/3 of the means 2/3 of that we will use from the materials point, then we will get. Actually, we are working means 2/3 of FI 3/2. I think 2/3 into 2/3 or that is equal to 4 by or 0.4 FCK of FCK purpose one as 44 FCK less than 50%, that at which level this is the one that 0.4 out. Similarly for the some other value we find out. So we are having, and then we are having this 1.15. This flow gives us the, there is nothing, so equal to Newton per square meter, and that will be same the strength by Fy by 1. So it will have the same Fy by 1.15 means, so this many times that one in our is 0.87 Fy. This is for another milestone compared to the other one we are getting in this particular phase. This one we are getting that particular stress. Now let us come taken it, though it is trapezoid, we take that one shape tree straight. Instead of though strictly speaking for FCK, that is the one, but we 5. So that way this is the one basic have, and explain this one because properly then you will be able to concrete. This is 0035 strain in concrete. Then here the first one, actually this particular one we have considered cold work deformed bar, that one here. So this one, this is to give you idea here, flat. That means have say that particular one at a particular, it will just yield, and then whereas compared to this we are moving and then we are going up to, so that means say you are having certain parabolic that we can. So this is the one say 415 Fe14, and so these two bars follow these characteristics. Consider irrespective of Fe5, Fe250, all of them yield is same. So that means if, and please note that one you will be asked in the draw a curve of stress 1.5, then you will draw it, but follow the same line with modulus of elasticity. Should remember. Coming back here, if that is the strain you are, that is true for a, but whereas epsilon SU, which is that one on the V, and as it is seen, which will be A15 ES plus point. So A5 ES plus 0.05 equal to 250, 0.0031, then you find out 0.0038. Please note actions demand plane before and after will be linear, but whereas the concrete, that certain portion having parabolic. Here we are considering, and then we are obviously equilibrium, that means the beam. So then what will happen? T should be equal, that equilibrium condition is equal. And now we make a couple and bending moment. So we shall, so as we can see, find out this one here, that is the one. So here this is the beam, and then we are a parallel, and somewhere here D say, let us consider, it will be clear because that means something is there at the, then only I can say C, and this one C will, second equation, this is we just Z, so C times Z or M is both ways, that means in terms of C or T. This is the moment, you can consider this one as a moment. If I know the section, you can say what will be the moment certain force D, then also I can calculate area of steel I have to provide. So one K2X top fiber. So this one from this, so this Z is nothing K2. So this is the one that K2X or Z equal to 1 minus X into D. By D one factor I can, when we shall get that factor one here corresponding Z. That is also K2X is the distance of the center concrete from the top compression. We are assuming the loads, and that's why that at the top. So now we have K1 and K2X. One whenever you are talking that K, so we can find out that this whole outer parabola, that outer parabola. If you really see 5 FCK into 0.45 x5, first I am considering this area is point, this is your X. If it is 0.45 FCK, and then we are going direction where we are getting B. You have to subtract this one, so 1 multiplied by this one, that is the one. So I can find which comes as 0.x into B or 36 FCK, that also, and this term FCK, that is we call it. So please note, this is one value actually that we can find out. Give you idea, please note, and just to give you idea, I told you here the section is parabolic. Getting that to 0.4 CK, this is the considering, and find out there. This is 0.45. Now, if we consider this is your, and these are CBC, which generally follow. So this will be C will be equal to CK by 3 into X. So the area is here 3 and this is X, and I am following that way, say normal to the paper, then we can consider this one. Nothing but 1/6 FCK. So particular one I can that value for another. This is the value I am going. Now what this particular one again, X by 3, and this we can find out here. See here, as I have told you, if I consider this, and this is another parameter I told you earlier, K2, this one also 2x, 0.333, this one is comes 416x. So that means in value that one remains, only this value are changed. Basic equation equal to C times D, which is nothing but D minus M equal to, or C minus K2x by D. So equation only, please note two value or this particular one here, which is not K1 B, here also FCK x, this portion, this K1 value will be pointing in limit state method. This is also another method 6 that Q1, but the equation would like to see a generic equation. Please note this one. If you understand at this stage it is difficult, but if you can read, then you have understood the exact concept. This particular one here, 0.364 here, very straight and partly parabolic 4, and I have given another working state method that where it's. So this is the one where I can find out the K1 and K2 for compression. Already I know C. I am taking the moment of interaction will be equal to, if we consider, then K2 0.42. 1 and K2 are two parameters. So one we are considering, and one you can consider 0.3, you can consider 0.41. So these two parameters, and you can to go ahead. So equal to K1 FCK and T equal to nothing but 0.87 Fy, 0.15 Fy by 1 is T. So find out one from the concrete. This C and T should be equal because if C and if one of them actually, then obviously it will become. So considering that as that one should be equal. That means if we then we can find out area of steel. That also we can. If I know the area of steel, I can find out value. We can find out. And T that this K1 important here that we have case limit state method one which you are 36 which you are 0.41 0.42 1 FCK x by D into 0.87 FYAS make this equal. There we can find out that we can find out x by D out in IS 456. These are the limiting values that are in concrete that we don't assume if it is which we are get 3.1 for XU by D. That AP 41538 and this for high yield state we are getting 0.0046, but it is always so one side or bottom portion if we assume that generally we assume at where we can go max which whatever you are in the other case always in the upper side always 0.0035. Tail areas for balance design balance say and both of them simultaneously strength very much unusual achieved, but anyway in concrete and steel we have achieved the maximum. That one for that case value 0.5 0.48 and whereas this PT Fy by F6 this particular one from the equilibrium C equal to T. Maximum or limiting value of L equal to F FCK it may be 20 30 and certain factor we are getting. Constants for maximum compression already I have told just to give that steel Fe2 500 XU the different values that particular K2 will remain same. D will change depending on concrete. So as I have sections in which reaches yield simultaneously as the ending balance sections. So that means when we really limit then we consider I say it is very different. And similarly when you are talking so similarly to find out that be two inequality because balanced means if I should be inequality also that is that one way it will be another one will be more. Still reaches yield strain lower than the low failure strain or section. So this is the one section and similarly we can section in which the failure earlier strain of steel is reached are called over reinforced. This is the one which is under reinforced section. We always because the concrete fail fast do not allow if concrete fails fast material and time it will fail immediately. It will give you to fail. Whereas in concrete, it may fail because the limiting. And we prefer under reinforced section. So this is the order here that I am not that. So that is actually requirement out that once a concrete core. The protection of the corrosion depends upon its thickness of good core. This is one is that corrosion, and then you have to find what you have to give. Obviously, that actually near C and out there that you are compared to the one. Or if you are in there also will find out more cover. So this is the one actually using the structure on the basis. Reinforcement up to 12 millimeter exposure the nominal 5 millimeter for exposure very severe reduction where concrete is M35. So maybe in the very beginning comfortable to hear only you will be with that one then you will understand importance of this. This one only it gives you things. So give you idea that importance of that as I have told you water in concrete. For me durability requirements moderate 30 very severe 50 25 like that. I can tell you here for buildings but and wherever or at the ground actually or one or they clear cover. Similarly, so if you really see that in the component that is slab cover where we provide to consider beam that 25 millimeter. I hope clear cover means end of the bar the beam or slab or collar cover. So similarly 40 millimeter we provide 50 millimeter and the different one we provide different clear cover. Now coming back I have just to give you idea about one. Let us quickly the issue is here why because I am going to object in this manner depending of the subject and here what happened. First of all please know your beam. I hope you have beam and slab the same day you cast to the very beginning that there are reinforcement not like that this first and that one it will be cast all whenever you will cast all together then we shall gain also it will contribute, and that's why we consider this here coming consider, because in your case I am preferring this one can consider, but where shall we consider? So one way that earlier, this is the portion we consider this one. Now this portion a flange, this one I can consider flange or slab. How far shall we go? How far shall we go this particular one? That what we similarly just is another one. That means if we consider in the end of the building, will whereas in the middle of the building sides. So that's why it is other one is called. We can say a slab as compression flange of satisfy A the integrally and obviously integrally with the wave and the slab shall be better in any other manner, because so that it will work. Slab is parallel to the beam shall be provided as in figure 3 shall not be less than the and mid span of the slab. Another one we have to consider, say that I have taken from IS2 that this portion less than 60% of you have to consider from IS4 L0 by 6 BW is this one BW and then we are having 6 depth of the flange. So put the value of B can calculate. Similar by 6 becomes L0. So these values we consider beam, this that we can find out. You can find IS code also, you can find out isolated beams, the effective flange in that particular fashion. I am just that different cases. This is very important here. I told you in the very beginning, neutral axis, being the neutral axis here can fall. That is number one case. Within the flange it can be, or neutral a wave here. It can be neutral axis here, or it can this one, or within this. Then you are like, because nothing but a rectangular beam. If the neutral axis come be two options, two further options, that this one or parabolic portion is coming, few options that can come. Then we can say uniformly stressed and stressed rectangular part, and consider that one as case. So we have here and B dot, that particular one we can consider, and case 3 where we are having uniformly stressed. That is a very, do not consider the cases, we case or second case consider there. So let me give you that the shear part, because give you idea about, and then we shall come to next multi-story building problem. Coming to this one here, diagonal tension, all that diagonal compression is there, diagonal tension is there. So where what is the objective shear? It will give you that, and as you know, teach. That means I have to. I can do it like this. I can provide normal to this one vertically. That is the one, because we have respect to longitudinal steel for the shear reinforcement and how much we have to provide. Coming to this one here, that the section bears certain section it's certain amount of. So an additional, this is the one that consider this one, this longitudinal, and then we find what will be the corresponding value. Failure, the shear tension we can have, and this is the one crack develop. Then we have to stitch. That means we have to vertically. So then we can have for different parts also we can have shear compression. We have here design. We have longitudinal steel, and we have to find out that also, because this one will take for. So what to find out that one uniform depth shall be BD. So we shall get the value divided by BD, that we shall be, B is the width of the beam depth. So we shall find out that one, and B is B effective depth. What is this is the one that we have to provide. Stir up in this fashion also. Longitudinal bar already we have provided. So this is the bending one we have to calculate. That means that how to do the as I can tell you here, and obviously the assume this way that I have that one. The way we are having similar fashion also we can consider to provide the reinforcement. Reinforcement will arrest this. That way you can consider that one, but out of the springs are very important here. By combined action of concrete, means concrete itself will take and shear steel. So the concrete is due to the converse shear carried by aggregate interlock dowel action. So these are the that is there. That means the that beam will take. Now just to inform you, students, you are asked one question, column you have to put not. Now in we always take a tie and heading that itself works here. Now in that, then for shear also one for column. Here what it is taken by the. Now how do I find out, know whether 20 to 40%, 15 to 25%? There is no such concrete value find out. So that's find out the strain by concrete, which is nothing but is VC equal to interlock, dowel action, other things. What we do, the percentage of steel in the basis of that we calculate is 456 if you have done where it is given in table 19, that particular one is given. And so total shear portion will be taken by the concrete, additional portion we have to give it. Okay, so there is one question. So let me come section here, it will be clear. What that when bar generally rate some bent and the one we can consider that bent of bar we can consider. Here as I have told you, longitudinal tension steel we are providing here that bar 15-25% means that particular 132. So whenever you are providing the reinforcement, longitudinal reinforcement will, and that one dowel bar we can known as actually here that for the beam and sometimes we do construct later on. So there you will find out in there are few bars, those bars you can consider as a that those bars will be bars of the beam and act together. Similarly, providing the reinforcement here tends mainly at the bottom. I am mainly whenever you are talking the bottom generally tensile steel. In that case, you can consider the development length other and find out that that you can take. One example it will be consider that one you take. Let us consider that few and then you tie rubber band. Load you will find out not falling, though the bars blocks are different but even not falling, and that is I hope that I could one example I could say that one matchbox you take and you just give, and if you provide find out that matchboxes all those, and then it is not take you just simply pick out the, all the matchboxes are actually. Now if you apply the load then you will not fall. So the rubber band is being used as a, so the main longitudinal dowel action. So we are having concrete up VC is coming from the or the percentage of steel. So this is the one because as I do not know that, so the code has specified percentage longitudinal percentage on the basis find out for M2 example you find out the strength of which is popularly known as this tau c will give me the key of that you can find out. Another value that is called tau c. The shear stress in concrete not go beyond certain value. I shall not go to, if it goes more than 2.1 you will not be able to change the section. So similar 0.1 that means if you calculate, so let that what we can that VU this is the shear certain and consider say VUA. So VU means VC VU plus VU. So this portion level 19 IS 456 on and this portion we shall provide steel. Let us say VU if let us say for M if this value get say 8 then that means to be changed. Then only value this should, so it should never be than 2.8. Now there is another code that maximum shall not exceed 0.7 shall not exceed per syrups at 40 where D is the effective depth and no case can limit. That means limit values 0.75 D for increment most of the cases, so we shall consider 0.75 go beyond 300 millimeter minimum consider here. So coming later, so what we are doing that so far we have covered beam covered here. Mainly we have two things. One is that bending, other one or we call it that one shear. For bend reinforcement like this. For shear we provide reinforcement fashion. Providing reinforcement we call it. Now in this one 8 millimeter. Now steel we V ASB. What is the area of steel? Pi by 4 square. Value I am getting for 1. Here I have 2. This is two-legged. So one will give me of steel for ASB. Here ASB, then I require SV spacing. So for beam I require bar. Just consider that how many bar consider. This is the reinforcement, and then stirrup two-legged minimum. Hold the stirrups at least 2 bars have to provide. We consider the cross section or consider the cross section of in this particular fashion. One we consider that one. So here that means I require bars, and this how many that particular one here at the rate fee. That means the spacing that we have to provide and how many bars we require, then that we have to find out that dependent on that head. So this is one way. Now one more thing I would like, let us consider here that there is a room. So whatever that is a beam, but have certain depth, more load or more depth is the depth. I have restriction that I shall not be then because I require this much, say I require something at clear height. Because of the beam that load applied, I require more depth, but I shall, but you shall know it is not possible. I would like to all of you, because the engine will always give the solution objective. We should solution in this case provide the reinforcement at the bottom, and that is called actually single reinforcement at only reinforced section. So now if there is a depth restriction the depth, then what I provide at the reinforcement at the, if we provide reinforcement at the section side, balance that one, as I have told you, means you have to increase here section, here whatever we are, this is the one we are having section, say something like that, we are certain portion I shall have maybe one more, I have to provide another one at the top, and this is doubly reinforced section. We have to provide to the solution, we have to come to the solution depth restriction, provide the reinforcement, and as well as very interesting one, very interesting understand, and I can be able to solve. What is the time now? Can you tell me? 12. Such all of you, few problems today only on concrete, but mainly I have beams only. What that singly reinforced section, I have given introduction to the effectiveness of T. I have come back to the CR. Solve the frame problem objective of that, so that this our utilize it there. Thank you.